Whenever I introduce equations to a class, I always compare the equation to a teeter-totter. It's a balance thing. The 3 plus the 2 on this side balance the 5 on the other side. And if I remove the 2 from this side, I have to remove 2 from the other side. Then it's still going to be balanced. Now, the most important thing here is the fact that you're doing the same thing to both sides. You're removing 2 from both sides. But the trick is, or the shortcut is, the plus 2 on this side we write as minus 2 on the other side. Now, when you come to a balance like this where there's a variable, what we're trying to do is trick the equation into telling us the answer so that we don't have to guess. You could guess that x is 10 because 10 minus 7 gives you 3. But if you don't want to have to guess, you just take that minus 7, write it on this side as plus 7, and now x balances with a 10 on the other side. So what you're doing when you're solving an equation is you're kind of tricking it into telling you the answer. Now, most textbooks go on and on with all the steps, all the proper steps to these, and many teachers in grades 7, 8, and sometimes in 9 insist that students write all of the steps. They don't like them using the shortcut. And most of them hate it. Whenever I've tutored them, they've said, why do we have to write all these steps? We know the shortcuts. I like to get to the shortcuts right away. I'll share another video with you that shows you all of the steps, and then you'll understand why they hate this stuff. But for now, let's just accept that if you've got a minus 7 on this side, you can put it over here as a plus 7. Now, let's look at a couple of equations. We'll take 3x plus 4 equals 2x plus 9. Now, I'm going to use the shortcut here. Now, what I want to do is get the x's on one side and the pure numbers on the other side. And what I'm going to do with this one is I'm going to keep the 3x and I'll keep the 9, which means I have to move this to the other side. That then becomes negative 4. I can put it behind the 9 if you'd like. Then it's 9 minus 4 rather than minus 4 plus 9, but it amounts to the same thing. This 2x I want to move to the other side, so because it's plus 2x, I'm going to write minus 2x. When I simplify this, 3x, take away 2x, leaves 1x, and 9 take away 4 is 5. If you want to check this, take that number and put it in the top line. If I put a 5 in here, 3 5s are 15, plus 4 is 19. Put it in here, 2 times 5 is 10, plus 9, again, it's 19. It balances. So what have I done? I took the plus 2x, put it over there as minus 2x, took the plus 4, put it over there as minus 4, and then I had the x's on one side and the pure number on the other side. Okay, I'll look at one more, and then I'll do a video with all the steps. Okay, 6x minus 3 equals 4x plus 7. Well, again, I could put the x's on this side, but then I'm going to be subtracting a 6x from 4x. I try to avoid negatives if I can. So what I'm going to do is I'm going to keep the 6x here. move the 4x to the other side so it becomes minus 4x. Leave the plus 7 over here and move the minus 3 over as plus 3. I don't have to write a plus in front of it because it's the leading term there. Now when I simplify, this is 2x. 3 plus 7 is 10. Now, if you get stuck with a number in front of the letter, what you do is you divide by that number. Divide, remember what I said, you're always doing the same thing to both sides. And when I divide by 2, I get 1x, and x equals 5. If you want to check the 5, 4 5s are 20, plus 7 is 27. If I put it in up here, 6 5s are 30, minus 3, again, is 27. So this is how you solve equations using a very simple process of moving terms from one side to the other. Take a look at the video that I'm going to share that does all the steps, and you'll understand why students hate doing it that way.